Hi everyone, good afternoon. Okay, we're going to do this for the first time, and let's see if this will work. It's really nice to meet you all. My name is Gizem Karagaz. I'm an Assistant Vice President at the New York City Economic Development Corporation. I sit within the Green Economy team under Innovation Industries. Today, I'd like to kick off this session by talking about the policy context of mass timber in New York City, specifically how it's a really well-positioned material to help the city achieve its building decarbonization goals. So before I go ahead and get started, I'd love to understand who's in the audience. Can I get a quick raise of hands to see who has previously worked on a mass timber project? Okay, so 2, 3, 4 hands. And how many people can explain what mass timber is to their non-technical friend who does not have a background in architecture, planning, or real estate? Half. That's awesome. By way of introduction, mass timber is a state-of-the-art technology that essentially uses gluing, dowel, or nail lamination in order to bring smaller pieces of timber in order to create larger structural components that are really well positioned to replace concrete or steel. So you might have heard of cross-laminated timber, which essentially combines smaller pieces in perpendicular ways in order to create structurally sound walls and floors. Glue laminated timber is facing in the same direction and essentially is often used as beams and columns. And nail laminated timber uses smaller dimensional lumber in order to produce larger structural systems. Collectively, we are seeing that mass timber is actually a really great uniform strategy in order to help replace concrete and steel. And there are a couple of different emerging policies or policy strategies that I think are coalescing in New York City right now in support of mass timber. So what we're seeing is embodied carbon is the next policy frontier. When we talk about embodied carbon, these are the carbon emissions that are locked in the materials of a building and also during its construction phase. And unlike operational carbon, you can't reduce embodied carbon once it's in your building. So what is the city doing about this? In 2022, New York City updated its building code in order to allow mass timber construction up to 85 feet for the first time. Following that, in Plan NYC, the New York City essentially outlined its first embodied carbon reduction strategy, 50% by 2033, first leveraging all city projects. And after the Plan NYC release, the Green Economy Action Plan came out on behalf of EDC in order to do a sizing and forecasting of all the job opportunities that are available in specific green economy subsectors, including alternative low-carbon building materials. What we're seeing, though, is a suite of different solutions are necessary in order to help the city achieve its carbon reduction targets. And these materials need to be very thoughtfully and strategically integrated into the built environment. And that doesn't happen by just purely developing the technology or the material by itself. So at EDC, we are bringing together a coalition of different programming and policy interventions that can help scale emerging materials from commercialization to market adoption. So for a material that is earlier stage, we support it through developing, prototyping, and de-risking the technology by access to public real estate. Mass timber is a really great opportunity where it's a material that is technically sound. It's been deployed in other cities and in other jurisdictions, but it essentially needs to be worked into the regulatory and the market aspect of New York City. And hence that's where the Economic Development Corporation's Mass Timber Studio comes into play. I want to really quickly touch on key benefits that we're seeing when it comes to mass timber. It is a material that is structurally sound. It offers great potential to reduce embodied carbon up to 60%, and also the potential to store carbon, and also presents an opportunity to be friendly in the neighborhoods that you're designing and building in. It can go up faster, it's quieter, it means less noise and air pollution, while also providing opportunities for New Yorkers to upskill and participate in the job of building with mass timber. But at the same time, we're seeing that it's a relatively new market in New York City. There is an opportunity to upskill and build capacity and the knowledge for all of the stakeholders that will interact with the Mass Timber project across its life cycle, beginning with architects and designers to agencies that regulate how a Mass Timber project is designed and permitted. And at the same time, the adoption of mass timber really depends on competitive pricing, which means that projects that are going first are taking on first mover risk. The New York City Mass Timber Studio is the city's attempt to proactively support industry development by bringing together a suite of partners across both public and private entities in order to support projects through their design and development. So the program is operated by EDC. It is in partnership with the Department of Buildings and the Fire Department, which are providing technical feedback and regulatory advisement. We have funding support from the U.S. Forest Service and as well as the Softwood Lumber Board. And together, this coalition of partners are essentially the first movers that are helping project teams go from idea to implementation. For us, in terms of objectives, they're two-pronged. So for project teams that we are competitively selecting, we are supporting them through the technical diligence and feasibility of how do you take a mass timber project and site it within the specific constraints of a New York City neighborhood or in the program that they're working in. We're also supporting them through industry connections, such as access to manufacturers or insurance brokers, trying to de-risk aspects of the project beyond just the technical feasibility of designing with it. And for the city, this essentially learning curve allows us to gain real-world insight in terms of what are demonstration pathways that can help us scale this, but then also what is the market readiness of doing this at scale? Where are there opportunities for future investment via supply chain or workforce development? And I think what we're seeing is a real ecosystem-wide approach is necessary in order to take one-off mass timber projects and to be able to scale them as a real solution across New York City. The way we work is there are a set of interim milestones and programming opportunities made available to the project teams. So the two main opportunities are feedback via our regulatory partners through monthly sessions with the DOB and FDNY, and then also technical feedback from our technical assistance provider, Woodworks. And in terms of the first two cohorts, these are just high-level numbers of what we've been able to achieve over the past 2 years. We run 2 iterations of it, supported 14 project teams, approximately 75 different participants have gone through the studio. And on average, we're seeing that projects are reporting between 30 to 40% reduction in their global warming potential when compared to alternative structural materials. And also, they are tracking how much mass timber could be used in lieu of alternative structural materials. I'll pause, I'll end there to make space for the other participants, but I would encourage you all to scan the QR code and sign up for the Green Economy newsletter. We are actively looking to partner with industry stakeholders really to advance mass timber in New York City. Thank you.
Alright, I'm going to try to talk from here and it's a little closer to the screen. Everybody hear me? Good. My name is Matt Melody. I'm an architect with Curtis and Ginsberg Architects here in New York City. We focus on designing large-scale multifamily housing in New York City and the surrounding area. We specifically focus on affordable housing and really high energy efficiency passive house building design. So we got interested in mass timber because, like was mentioned on the previous panel, and I think even the panel before that, passive house design creates a real reduction in operational carbon, but we weren't finding a way to reduce embodied carbon. So we got involved with the Mass Timber Studio that EDC put on and did a study of how to design a new 100% affordable housing building out in Jamaica, Queens. And I'll walk through the things that we learned along the way, how you can design these sort of large-scale multifamily buildings in mass timber. So, like as I mentioned, mass timber comes in sort of a variety of flavors. We focused on cross-laminated timber, that you see in the image on the right here, and glulam options. So CLT effectively is like gigantic plywood, right, of dimensional lumber that's all been bonded together. And then glulam, we all know what glulam is, columns and beams out of that. So when you're designing a large-scale building out of mass timber, you have like roughly 3 general approaches to the structural system. You've got post and beam, which is glulam, columns, beams, and then mass CLT floor panels. You have an all CLT system, which is the walls and the floor are all CLT mass timber, or you have a point supported system, which is glulam columns and then CLT slabs spanning in 2 directions. New York City Code, like as I mentioned, allows currently what is effectively a modified type 4C construction. So we can get up to 85 feet of mass timber, 7 floors within that. International Building Code, the new New York State Building Code allows for a bit more height variation in mass timber, but for New York City, we're a little more dense, so we're a little more conservative on it currently. So, when designing the building out in Jamaica, Queens, we maxed this out. We have a cellar, parking, and ground floor commercial that is cast in place concrete, and then 7 floors of mass timber up above that. I'm going to pause a minute, and since we focus on affordable housing, I'll give a little intro on how affordable housing design works and how that integrates with mass timber. In New York City, affordable housing is governed by the Housing Preservation and Development Agency, HPD, and they have some very specific design guidelines that go above and beyond regular building code. So, props to HPD, they do that because they want to make sure that affordable housing is also good housing. We have very specific room dimensions, areas, and unit areas to make sure that the apartments are really livable and right-sized for families. So we have to meet all of those design guidelines in addition to building code. A lot of affordable housing in New York City is built out of concrete precast plank structures with CMU walls. So you have these big, like column-free spans throughout the building, and that's sort of what the design guidelines are based on. So they're not used to dealing with a lot of columns. So, you're going to design an affordable housing building using CLT. The first one we looked at, the first system we looked at, is a 9-ply CLT system. So the thickest you can get. It's got a long, roughly 27-foot span, very similar to the precast plank approach. We could fit the design guidelines, the apartments fit out perfectly fine within that. The only consideration is that 9-ply CLT, not all that standard, not all the suppliers provide a 9-ply system, so we were somewhat limited in who we could go to. Another option is a 7-ply CLT system. It's thinner CLT panel, the span is not quite as long, so we flipped that, expand that between demising walls, and it works out pretty well for 1-bedroom apartments in an HPD design guidelines setting. When we got to the larger apartments, the 2 bedrooms, the 3 bedrooms, the span limitations weren't really working with us, so we started to run into some inefficiencies and conflicts there. We tried the all CLT 5-ply system where all the walls and the floors are all CLT. This one, the rigidity of it and the sort of short span spacing doesn't work quite as well for affordable housing. And room dimensions that we have to meet. The last one that we looked at is the point supported system, so just the glulam columns and the CLT floor plates. This one has the lowest, the shortest amount of span available in the system, but it works out reasonably well with the design guidelines items. So we analyzed all of those along with Merrill Happel, who was a partner on this, to see which of the systems had the least amount of wood fiber in it. When you're designing mass timber buildings, the more wood fiber means the more embodied carbon means the more material cost. So if you can keep the amount of wood fiber low, you can keep the cost and the embodied carbon down. So of those, the 7-ply system and the point-supported system had the lowest amount of wood fiber in it, and the sort of Goldilocks option was the point-supported one, since that had the lowest amount of wood fiber and works the best with the design guidelines. So after that, you picked your system, extrapolate that out over the entire building design. You still need to factor in that we can't use currently mass timber in your lateral resistance frame. So your shear walls, your stair cores, your elevator cores are all still going to be non-combustible concrete, CMU blocks, something like that. So we end up with a hybrid system each time. I'll talk real brief about Passive House. I think Eric's going to talk some more on it. Passive House and mass timber go hand in hand. You get some good benefits because your thermal break systems can be somewhat reduced because timber has lower conductance than, say, metal or concrete systems. The one trade-off we have is that in a mass timber system, we can't use high R-value foam plastic insulations. So you end up with an all mineral wool insulation system, so your exterior wall assemblies get a bit thicker. In the end, we found that we were getting about a 30% embodied carbon reduction compared to a regular block and plank building, and that's before even counting savings from the foundation reductions. So all that to say, on Gizem's point, the best option we have right now for reducing embodied carbon is through building with mass timber. And the more that we can do it, the more people will get used to it, the cost will hopefully start to come down, and we can really build this at scale.
Hi everybody, I'm Eric Lifton. I'm an architect and principal at Mesh Architectures here in New York, where our office is in Brooklyn. And we've done a lot of different kinds of projects, but for the past 6 or 7 years, we've been really focusing on mass timber projects. Pretty much for the same reasons you've been hearing. It's made out of plants, it's renewable, it's beautiful, it makes people feel good, and it has a lot of other benefits as well. So, it's kind of cutting off. All right. So, as you know, one benefit of using mass timber, like CLT, low embodied energy, sequestering carbon, and it's renewable, it goes up quickly. And so we decided to jump in the deep end of this pool and do some building in. One note is that, there's some wood right there. One note is that, as Matt says, it goes really well with Passive House design and the principles of Passive House. Wood is already not a thermal bridge like concrete and steel are, but it is a kind of insulation. It's not as good as the insulations we normally use, but it's pretty good. And it makes, it just, the ethos of building in mass timber and Passive House really go well together, so they just kind of reinforce each other. This is the first project that we built in mass timber here in Brooklyn in Park Slope. It's called Timber House, and it is a glue laminated timber plank and glulam post and beam construction. And it was our first foray into this, and it worked out really well. I can tell you a little bit about how that went. So that's a little section of the building. one thing is that you start out by building a very accurate model of the building in Revit. And so having an extremely accurate model ensures that the wood that shows up on site will help everything go together perfectly. One thing is then we test the inside of the buildings using VR. This is actually from like 6 years ago. It looks a lot better now, but this is something we do to really understand the spaces we're building. Again, with our very accurate model, we can check out everything from the inside. One thing that's super important is that there's a lot of coordination before you. A lot of your work with mass timber is all done in advance. So this is penetration coordination. So these are all the penetrations from mechanical, electrical, plumbing penetrations. Those are all cut in the factory, and the planks all come pre-cut for services to go in. And so there's a lot of time spent making sure that you have all the right locations for all those penetrations. Similarly, shop drawings are really important for determining the connections. Again, everything is established in advance, so when it shows up on site, it just gets through together. So there's a lot of time in advance while your foundations are going in, coordinating all of these planks and beams and columns, making sure they're set up properly. This is what some of the connections look like. They're very specialized connections made for mass timber. What that means is that when everything shows up on site, all you need is a small crew with screw guns and a guy in a crane to put your whole building together, put the whole structure together, which is extremely satisfying because everything goes in very quickly, without a lot of waste, without the mess of concrete, and you just have guys assembling the whole thing as if they're putting together IKEA furniture. This is again a shot of how it looks going in. We do have a CMU core. You cannot build your core out of mass timber in New York City. Now, we reveal all of our nice wooden ceilings throughout the building. So what that means is that all of your services, your sprinkler, your plumbing, your electrical, your ducts, all your ERV ducts is also, all that stuff gets put into very small spaces. The code also asks for very few concealed spaces in mass timber buildings. So everything gets jammed into very small cavities and is very close together. Also needs to be coordinated. We, of course, have air sealing. You can see on the left, that's what the air sealing looks like. We have ERVs, which are providing fresh air constantly to all the spaces and exhausting all of our stale air, which makes for a very healthful and pleasant environment inside the spaces. So here's what it looks like going in. You see a concrete surface there. That's not a concrete deck, as you might expect. It's a very thin concrete surface that we put up on top. That's part of the fire-resisting assembly that we have, and it also helps with acoustical control. And there's the final space of the same one, that there, before and after. And so you can see everything is finished there. This is a time-lapse video of everything going up. So you can see how we have our beams and columns going in, the planks going in on top of those. Then we have that concrete surface I mentioned going in. You can see the whole thing getting erected here. We have a concrete firewall on the sides that's made out of CMU. Again, we cannot use mass timber in our fire-rated exterior walls there. So we're putting everything up, and it's going to top out very quickly. But you can see it goes in extremely quickly in this video, but it actually does go in quite quickly. It would take about a week to do each floor in timber, then a week for the concrete that you see, and then you repeat the process the following week. And these are the final kind of finished pictures. You see the wood is exposed, which is great for the feeling of being inside this kind of natural environment. Everybody really loves being in these spaces. And then the outside is clad in these handmade Danish bricks. This is a project that's going in right now in Williamsburg, also here in Brooklyn. And this is a single-family house that's made also out of glulam beams and columns and CLT partitions. So you can see how it goes in here. You just have a crane and everything gets dropped into place. On the right is taken about a week and a half ago of how it looks right now. The structure went in incredibly quickly, again, once we set everything up. And this is just a video of one thing that's tricky is if you're working on a small street, like as we have here in Brooklyn, I mean, not where you're at here, but you get the point. We have these large pieces that have to come in on a truck and get craned in. And this piece has already been, had its membrane adhered to the outside of it, which is going up against another building. So you can see how it comes in here. But you don't need a big crew, it just goes in and gets screwed into place. Then we're also doing some projects upstate where we're doing houses, and this gives you a little more latitude. We're not working in very constricted Brooklyn spaces. And you can see how CLT also gives you an opportunity to use it for architectural expression. You get to cut these shapes and make a lot of different kinds of forms. So it's both practical and beautiful at the same time. And the last project I'll show you is one that we're planning right now. This is a row of 5 houses. This is the one that we did in the EDC's Mass Timber Studio. And it's going to be 5 houses in a row. And they're single-family houses. You get these really beautiful interior surfaces made out of natural wood, and you get all kinds of different feelings for these spaces. You're doing a wood stair, and it's a lot of opportunities for both practical and aesthetic experiences. So it gives you a sense of that. The way we insulate our buildings, we have a very thick envelope, as Matt was describing. We have mineral wool on the outside. We have CLT walls, but they're panels, but they're not allowed to be load bearing on the exterior of the building. And then we have a CMU core for lateral forces. One thing is we're using very sophisticated air-to-water heat pumps, ERVs, and solar for energy generation. These are the bricks, the same ones we use in Timber House. And I want to just talk briefly about some of the obstacles that we face doing this in New York City. One is the Building Code Chapter 33, safeguards during construction. There's a lot of restrictions that make it difficult to build. And these are things I think will be worked on in the years to come to make them a little bit more friendly to doing these projects. But right now, there's a lot of restrictions that you have to be mindful of. Another thing is that lateral systems cannot be made out of CLT in New York City at the moment. We hope again that will change in the next iteration of the code. But we have to use CMU as our lateral system. And all of our connections, normally you think of steel connections in New York City have to be fireproof with intumescent paint or some other kind of spray-on fireproofing. In timber, it has to be done with wood. So that's another thing you have to be mindful of. So this shows our structure with the CMU. If I make that transparent, you can see the combination of the post and beam construction with the CMU construction for lateral resistance. And we do save a lot of global warming potential. The embodied energy is great here. In the structural engineered analysis, it's 20 or 25 to 30% from baseline. When we put it through Tally, our whole model, which includes also using not as much sheetrock, not using as many finishes that you normally use, the GWP is a lot lower compared to the baseline using mass timber. And that's it. I'll have some questions.